Hello everyone, welcome to the channel. I've made this channel to try and tackle some fun and interesting integral problems and to try and educate you guys and make maths fun along the way. And I'd like to quickly credit Andy's Math as he's been my inspiration for making this channel. Cool, so let's dive straight into it. So this is the problem I found, and I actually found this problem on a website called Daily Integral, and they're a really good website. They produce calculus problems for you to try every single day, and I'll definitely recommend checking them out. Perfect, so let's dive straight into it. Cool. So the first thing I'm thinking about when I'm attempting this integral is to try and deal with this fraction, because it looks quite awkward to integrate straight away. I feel like it would be a lot easier if we could divide it out and try and deal with a smaller numerator or a lower power numerator in the fraction. So writing it in this kind of form, where I have some kind of polynomial and then a lower power of x, just a x and a constant on the numerator, so that's a lot easier to tackle. Cool. So I think the easiest way to do that, or the way I'll do it, is using long division. And when I do long division, I like to add these zero coefficients, any missing powers, just so that it's a lot easier to, my working out's a lot clearer, and which means you'll make less mistakes. And let's get straight into it. So if I divide x to the 4 by x squared, I'll get x squared. And then, of course, I need to see what I'm taking away from this polynomial to just have an x squared. So I need to multiply this polynomial here by x squared, and that'll produce this. X squared times x squared is x to the 4. X squared times minus 2x is minus 2x cubed. And the same thing with 2 times x squared, you get 2x squared. Cool. And then I need to subtract this here from my polynomial, and so that, and you'll produce this. And so that means now I have an x squared on the outside, and I don't need to worry about it because I've already subtracted from the polynomial. And then you can just repeat the process. So 2x cubed divided by x squared will just produce plus 2x, and then multiplying this polynomial here by 2x will produce this, and again taking away will produce this, and and then you can repeat the process one final time to get plus 2 here, and multiplying everything out by 2 will produce this, and remembering this plus 4 over here, this all will produce a remainder of 0. So we can then say that when I divide x to the 4 plus 4 by x squared minus 2x plus 2, it will produce this polynomial, this quadratic, with no remainder. Cool, so let's just put that on the side. And then looking at what I wrote here, I can sub this in, so I know then that fx will be this quadratic here, and since there's no remainder, a and b will both equal 0. Cool, that looks quite important, so we can put a box around it. And then we can sub this into the integral. So there you go. And this looks like a much easier problem to deal with. And we can do this by, we can deal with this problem by power law. Here's power law, just in case you don't know it. And by using power law, you expand the integral to be this, and simplifying the x squared coefficient, you'll produce this. And if you sub it in, if we sub in the original bounds of 1 and 0 in, it'll produce this calculation, which is, so 1 over 3 is the third, plus 1, plus 2 times 1, which is 2, minus 0, because you times any of this by 0 equals 0. Get 10 over 3. And if you're doing this challenge on Daily Integral, they would ask for it to 2 decimal places. So here's the answer in 2 decimal places, and we can put a box around it. I hope you enjoyed the problem, and I look forward to seeing you guys tomorrow.